Hello, and welcome to our presentation about measurement for grades 6 through 8. I'm presenting on behalf of myself, Yesenia, Nisha, and Megan. So we're Group F, so we have decided to talk about the NCTM and TEKS standards in regards to grades 6 through 8 and measurement. We're going to notice the progression as we see the idea of measurement and what each standard expects of students and what the progression is through different grades. Through each document, we're going to really see into detail what the standards are actually requiring students to learn and understand. So it's something just to keep in mind because as we teach as educators, it's always important to know how we should progress our students' knowledge and information, feeding off of one topic to another. So one of the first things we're going to start off, being lovely and from Texas, we will start with the TEKS. The first thing we're going to talk about is our 6th grade TEKS. Now, if we look at the given TEKS, we do see some of the bolded words, and these are some of the key facts that we've noted to be involved with the TEKS and the standards regarding measurement. Now, if you look at the 6th grade TEKS, we do notice that converting units of measurement is one of the first things that are enforced. One of the standards that should be carried from earlier grades is reinforced back during 6th grade. So converting units regarding the measurement system really ties into proportions and unit rates as well. So students are going to get the opportunity to talk about units and rates. Along with this, we see an extent of measurement dealing with geometry. We do see the inclusion of triangles with the sum of angles, along with various shapes and figures. Now, area was the big thing I want to show on this slide regarding, for example, parallelograms, trapezoids, triangles, rectangles, triangles, and volumes also very present along with these standards. There's about 3 or 4 standards just on area and volume. So we can notice that this year, 6th grade, is one of the big moments where they want children to really understand area, being able to model, derive equations, and get into solutions, which is a lot of the new material that students are being introduced to this year. However, they're applying it to their measurements and geometry understandings. To continue on, we do include our coordinate grid. Coordinate grid is, something that students just start to learn with maybe late elementary school, early middle school, and really get an understanding of locations on a plane. So we get planar geometry along with graphs and data. So we see that graphs and data go along with measurement and data just because we do see that there is a measurement of different units presented in data, such as distance, time, speed, etc. Back to locations on a plane, we do see that students are expected to find out being able to go in all 4 quadrants, being able to use distance, being able to use ordered pairs in a sense of measurement. One of the last things we see for 6th grade is representation to solve problems, meaning that they're going to use all this measurement data information that they've learned over 6th grade, incorporate them into problems. So we see the 6th grade TEKS is very heavy on these topics, but what gets interesting is how it continues to stay relatively the same but increase with 7th grade. The 7th grade TEKS really presents itself with very, very heavy geometry. 7th grade gets a little bit more in depth, as we notice, as the first standard is the circumference of a circle to its diameter, talking about ratio. We see a lot of geometric relationships and a lot of congruency and a lot of figures being represented, such as the rectangular pyramid, triangular prism, just on this slide alone. We see a lot of strength and a lot of that geometric understanding come in 7th grade. Now, granted, we don't see too much of the units and area. However, we do see how area, angles, and planar geometry do fall into 7th grade. So we do see how 6th grade TEKS really progress into 7th grade TEKS, preparing and getting ready to have a year's worth of geometry. Very, very much in depth. So to finish off the 7th grade TEKS, we do, like I mentioned, a lot of geometry. If you notice, almost every other standard on this slide really goes into detail about using geometry. So that is something to remember. Okay, so following that, what we are going to talk about is how geometry is really understood as that 7th grade TEKS standard. So let's move forward into 8th grade. So 8th grade TEKS, we really do see that talks about expressions and relationships, really going into geometry, algorithms to the point of formulas. So here we actually see volume being really focused and determined on relationships, equations, and really strong understanding. We see that students are expected to understand volume as well as go more in depth with surface area. And we do see Pythagorean theorem make a huge presence. That's one of the newer things we see in these TEKS versus the 7th grade TEKS. 7th grade doesn't really hit the Pythagorean theorem, however it does focus on geometry. So it's interesting to see how we move from the 8th grade TEKS. It's interesting to see how we move from the 8th grade TEKS all the way. Sorry for that disconnect. I know I stopped mid-sentence, but I just want to re-emphasize on how the introduction of the Pythagorean theorem is really seen in the 8th grade TEKS versus the 7th grade TEKS. And we do see a lot more volume and a lot of volume and shapes being represented in 8th grade. Along with this, we do see the continued presence of geometric problems and equations and expressions carried from 6th grade, seep into 7th grade, and finally again in 8th grade. And we do, like I mentioned, the Pythagorean theorem makes a huge presence, and we do go into statistical data information as well. So talking about the TEKS, we do see that it's broken up into different grades. It expands itself from different grade groups, repeating itself constantly. However, it is feeding off of, and it's still increasing. It doesn't go into the idea of shapes as a form of measurement, but it does go through expressions, equations, and the relationships in geometry to really derive measurement, such as angles, perimeter area, and surface area. When we talk about TEKS, it does review it as data, and we do treat it as such. So it does really focus on measurement in that sense and that element. Now, talking about NCTM, it's a very different guidelines. We don't see the NCTM kind of divided into various age groups or grade levels, just simply 6 through 8. So these standards are actually the ones that are included with just measurement. So we do see one half about understanding, and we do see another half about being able to comprehend and execute. So we do see that understanding measurable attributes is something very strong at NCTM. All of the 6 through 8 content that I went through with the TEKS is very much condensed here with NCTM. We do see that it does talk about measurement, however it goes into the sense of metric and customary. And it does highlight that, even though it is included with our TEKS. However, it's not one of the bold-faced, standards that are out there. We do see conversion relationships within systems, as well as the shapes such as perimeter area, surface area, and volume, and angles, which was also mentioned in the TEKS. Now, here's where we really see a lot of increased interaction from the student. We do see that they want to be able to apply particular techniques, tools, and formulas to determine measurement. Now, rather than just determining it, like the TEKS was very much about understanding, applying, and incorporating measurement. However, NCTM really wants to focus on using techniques to gather information and kind of hone in on measurement. Students are using formulas, students are using context clues to solve these formulas, and we see a lot of emphasis on the geometry factor. We don't see much leeway between geometry. We do see it overwhelmingly, about 4 or 5 actually of the main points is dealing with just geometry. We do see 6th grade, 7th grade TEKS kind of way in between units and scales, and though it is a realm of geometry, it is separated out. So I do feel that our TEKS do provide a little bit more of a rigorous standard. So what about them? We do see the progression of NCTM if you compare it to previous year's standards, that there is a slight increase. However, for 6 through 8, there isn't a gradual increase to the point where we can see developmental changes from 6th, 7th, and 8th grade and the incorporation of particular standards or content. With the TEKS, we do see that change. We do see 6th, 7th, and 8th grade integrate and become much more progressive with the material given to them, meaning that we do see a gradual grow in the knowledge of measurement with 6th, 7th, and 8th graders in our TEKS. However, with NCTM, it's kind of hard to understand because they're all grouped together, which is something, kind of different. However, NCTM does set a standard on helping students understand what they want them to understand as background information and applicable information, versus the TEKS standards, which kind of hone in on knowledge that they want the students to know, and it also does go into a little bit more applicable standards However, it might be a little bit too much to the point, not where like the NCTM standards where you can see what the student should get overall versus what you should get per year with the TEKS. So this discussion could go on for days. However, we do see that TEKS have various differences and NCTM has different differences also. But what we both derive from both of them is the strong increase in understanding measurement and understanding, math as we progress through the middle school ages. So thank you so much for listening. If you have any questions, feel free to contact us. Thank you.